Hello, my name is Grant Logston. I'm with Elizabethtown Community and Technical College in the machining program, and this is a lesson on reading the Vernier Caliper. Not used much anymore today, but we still want to learn how to read these just in case. It's very similar to the height gauge, Vernier height gauge, the Vernier protractor. There's other Vernier instruments. We have a Vernier gear tooth gauge, but this is a Vernier caliper. It's a 6-inch caliper. Instead of having a dial, it has a sliding scale. There's really not much to it, but they're somewhat difficult to read. So this particular caliper is a Craftsman 6-inch. So we have the inch scale on bottom, the metric scale is on top. So with the inch scale, each of these tick marks here are going to be 25 thousandths, and we can see that on the sliding scale. So as we go down through this list here, we see a little bitty one right there. That's 1 inch. Okay, so what we want to look at is not the end of the sliding jaw, but we want to look at this zero. This zero is going to be our reference point. Just imagine an arrow at the end of this zero and you'll do fine. So we see that there is a 6. That's 600 thousandths. And each of these tick marks are 25 thousandths. So we have 6, 625, 650, 675, 675 thousandths. Well, we're in between 675 and 700 if we use this zero for a reference mark. And then we look down the Vernier scale and see which one of these numbers line up with a line on the opposite side on the beam. So we see that the 20 looks like it's lined up just almost perfect. So then that would give us 625, 650, 675 plus 20 thousandths that's lined up here. And that would give us 695 thousandths, as that's the measurement. So we have 6, 625, 650, 675, and then we read. The next step is to read what's on the sliding scale that's lined up and get that number there. And then we just add those two numbers together. 675 plus 20 is 695. Now on the other side, it looks like we have the metric, and you'll notice a 1 over here. Well, that is not 1 millimeter. That is 1 centimeter. So what we do as a machinist, we need to convert that to millimeters, and all we do is add a 0 to it. So that's 10 millimeters. So we have 10, 11, 12, 13, 14, 15, 16, 17 millimeters, and we're in between 17 and 18. So that's where this sliding scale is going to come in handy. That's the Vernier scale. So we have 17 point, whatever this may be, and again, remember this 0 is our reference line. Just imagine that 0 has an arrow at the end and look at what it's pointing at. Don't look at the end of the beam, don't look at the end of the sliding scale or anything else. Look at this 0. So we have 10, 15, 16, 17 millimeters plus whatever this reads up on the Vernier scale. And it goes by fives, 0.05 millimeters. So it looks like the 6 is lined, it's right past the 6. So it'll go 6, 6, 5, 7, 7, 5, 8, 8, 5, 9. So it looks like we're at this point right here, which is actually 6, 5. Okay, so in between 6 and 8 we have a 7, and then between the 6 and the 7 we have a 5 there. So it's the measurement that we get in the metric here is going to be 17.65 millimeters. We don't work with centimeters, we work with millimeters. So on the inside we have 6.95, 0.695, and on the metric we have 17.65. So it's a very simple instrument to read, but you've got to have very good eyes. That's why we use a magnifier many times like this. I have a magnifier that I can use to look at the lines that line up a little bit easier, and it is a lot of help. So I hope this will help you as you practice using this instrument. And if you have any problems, come and see me. I will help you anytime. Thank you so much.